Welcome to the Discrete Universe podcast. Today we're tackling one of quantum physics' biggest head-scratchers, the double-slit experiment. Now, if you've got a physics background, you're already familiar with the whole wave-particle duality thing and, those baffling interference patterns. What we're diving into today is how quantum geometry dynamics, or QGD, offers a completely fresh way to look at this. It's built on the idea that space is discrete and, crucially, that everything happens for a reason's strict causality. So forget the usual talk of wave function collapse for a moment. QGD paints a picture where the double-slit results naturally emerge from the quantum geometry of reality itself and the interactions of these fundamental bits called preons.
Right, the double slit experiment often feels like, well, like a magic trick, doesn't it? How can a single particle seem to act like a wave, go through two separate openings at once, and then create an interference pattern? Standard quantum mechanics has its explanations, of course, but QGD comes at this from a very different set of foundational ideas.
Exactly. And before we dive into how QGD explains this mind-bending experiment, let's really nail down its core principles. What are the absolute must-know concepts in QGD?
Okay, first up is the idea that space isn't smooth and continuous like we usually imagine it, not at the fundamental level. In QGD, space is fundamentally discrete. It's composed of tiny units called preon. The familiar Euclidean space we experience day to day, that's more of a large-scale approximation. Then you have the fundamental building blocks of matter itself. These are the preons plus. These preons plus bind together through a fundamental force, which QGD calls P gravity, to create all the particles we know. And here's a really key point. These preons are eternal. They always exist, and the total number of them in the universe is fixed, constant.
Eternal and a fixed number, that's a pretty fundamental departure from some other models, yeah.
Right.
What's the second pillar?
That would be the principle of strict causality. Essentially, it means that every single state of a particle or a system is a direct and unique consequence of the state that came immediately before it. There's just no room for spontaneity or things randomly popping into existence. Everything has a cause, a direct cause.
Okay, so discrete space made of preon units, matter formed by eternal preon plus units interacting via P gravity, and it's all governed by strict causality.
Got it. Now, how do particles actually move and interact within this QGD framework?
Well, in QGD, particles are seen as these stable configurations of bound preons plus. Their velocity isn't quite like in classical physics, changing with time or distance. Instead, it's an intrinsic property. It's defined by the ratio of the particle's momentum vector to its mass.
Intrinsic, so independent of time and distance. That's right. And interestingly, for photons, this intrinsic velocity is the speed of light, c, which in QGD is also the fundamental speed limit for the preons plus themselves. When particles interact, say, they collide or absorb or emit something, they exchange momentum. And this happens through exchanging preons or photons, which, remember, in QGD are themselves made of pairs of preon plus.
Right, so movement is intrinsic. Interactions involve momentum exchange at this foundational preon level.
Okay. Let's finally get to the double-slit experiment itself. How does QGD make sense of those interference fringes without waves?
Okay, here's where the QGD perspective gets really interesting, I think. Instead of a particle somehow existing as a wave and magically going through both slits, QGD explains the patterns as a result of reflection.
Reflection, off the slits. Off the edges of the slits, specifically. When a photon, which, remember, is a pair of preon plus, approaches the slits, its angle of reflection isn't random. It's determined by a very specific equation. Cos. Here is the reflection angle is the incident angle, and t is the momentum of the photon. The IXME part relates to interaction parameters.
That's a very precise mathematical relationship. What does that equation tell us about how the pattern actually emerges then?
What's really insightful here is that this equation implies the interference pattern isn't one holistic wave phenomenon. Instead, it's built up from countless individual deterministic interactions. Each photon, each preon plus pair, interacts with the physical edges of the slits. The force governing these interactions at this tiny scale is P gravity, acting between the preons, combined with the photon's overall momentum. So basically, each photon hits the edge and bounces off according to this strict rule. Deterministically.
So it's not some kind of, spooky action where a single photon is somehow aware of both slits simultaneously.
Precisely. In the QGD view, the wave-like pattern of bright and dark fringes we see on the screen is a statistical outcome. It comes from a huge number of photons, each undergoing this discrete causal reflection at the quantum geometrical level, at the edges. It's not because a single particle is delocalized and propagating through both slits as a wave. That whole picture is just bypassed.
That's a completely different way of visualizing it. It sounds much more concrete, almost like a billiard ball interaction, but at this fundamental prion scale.
That's not a bad analogy, actually. By focusing on these fundamental, discrete interactions governed by strict causality, QGD avoids the need for some of the more abstract interpretations you find in standard quantum mechanics. Things like wave function collapse or pilot waves, they just aren't necessary in this picture. The interference pattern arises naturally from the collective behavior of many photons, each following a deterministic path defined by that reflection equation.
This really is a stark contrast to the standard quantum mechanical picture, isn't it? What would you say are the key philosophical or maybe conceptual differences between the two when it comes to explaining the double slit?
Well, the most significant difference is probably the shift away from probability and continuity. Standard QM is inherently probabilistic, right? It uses probabilities to predict outcomes and describes particle evolution with continuous wave functions. QGD, on the other hand, grounds everything in these fundamental entities, the prions, and their direct, strictly causal interactions. It's discrete and deterministic at its core.
And deterministic is the key word there.
Absolutely. Furthermore, QGD treats time differently, too. It's not seen as a fundamental dimension like space. It's more of a relational concept, useful for describing how dynamic systems evolve. That's another major departure from the standard view. So yeah, where QM often talks about inherent uncertainty or randomness, QGD posits a fundamentally deterministic reality, just operating at a level we don't usually perceive.
So QGD is providing a deterministic explanation for an experiment that's almost the poster child for quantum weirdness and probability. What are the broader implications of this QGD perspective? And importantly for our audience, does this explanation of the double slit lead to any specific predictions we could potentially test?
The implications are pretty profound, yeah. If QGD's explanation of the double slit holds up, it definitely strengthens its broader framework. As we've talked about before, QGD also offers alternative explanations for things like gravity, dark matter, and cosmological observations, all stemming from these same core principles.
Right.
Regarding testable predictions, specifically from the double slit, that reflection angle equation is the key. Now, the source material we're looking at doesn't lay out specific experimental designs, but the equation itself does suggest something interesting. It suggests that under very, very precise conditions, we might observe subtle deviations in the interference patterns compared to what standard quantum mechanics predicts. The challenge, of course, would be designing experiments with enough precision to actually isolate these potential QGD-specific effects. That's non-trivial.
Understood. So, wrapping this part up, what's the big takeaway here regarding the double slit experiment through the lens of QGD?
Okay, so what does this all mean for you? Well, for those of you with that physics background who are maybe looking for a more, let's say, intuitive or causally grounded understanding of these quantum phenomena, QGD offers a really compelling alternative. By rooting the behavior of light and other particles in the actual interactions of fundamental prions within a discrete quantum geometrical space, it provides a framework that neatly sidesteps some of those conceptual hurdles, the ones associated with wave-particle duality and wave function collapse.
And here's where it gets really interesting, I think. The double slit experiment is so often held up as the prime example of the inherent weirdness, the probabilistic nature of quantum mechanics, QGD's ability to offer a fully deterministic explanation. Well, it opens up fascinating new ways to think about the fundamental nature of reality itself. This deep dive into QGD's perspective really invites you to ponder this question. Could this seemingly probabilistic nature of the quantum world we observe actually be an emergent property? Could it arise from a deeper, discrete, and strictly causal reality operating down at the level of prions and quantum geometry?
And thinking further, if that's the case, what other quantum puzzles might yield equally compelling, maybe even simpler explanations within this kind of framework? It raises a significant question for you, our physics-minded listener. If the underlying reality is indeed discrete and strictly causal, like QGD proposes, how might that influence our approaches to other fundamental problems in physics? Could it perhaps point us towards entirely new experimental avenues we haven't considered?
Lots to think about there. Thank you for joining us on the Discrete Universe podcast. We definitely encourage you to explore the principles of quantum geometry dynamics further and really consider the implications of a fundamentally discrete universe.